right, welcome to video 2 of 3 for ratios in similar solids. So before we set up a chart to help us jump between the ratios for linear, area, and volume. Now we're going to use that chart to help us solve for a length, an area, or a volume. All right. In order to do that, we need to first get down some steps. The first step is going to be find the ratio of the scale factor. All right, so we want to work our way back to that linear column if we aren't automatically given it. Okay, our second step is going to be use that scale factor ratio to calculate our desired ratio. All right, so if you look over here, we're missing our volume of our smaller solid, so we're obviously going to look for that volume. So that means we want the volume ratio, so that's going to be our desired ratio. Once we get that desired ratio, we're going to use that ratio to set up and solve a proportion. So use ratio to solve proportion. All right, we have done that multiple times throughout our similar triangle unit. Okay, so let's try this first example. So we know that we're going to have to, step 1, find the ratio of the scale factor. So I'm going to go ahead and set up my chart. So I have my linear, my area, which I know its units is squared, and my volume, which their units are cubed. So I'm going to set that up like so. I'm given that the larger solid has a surface area of 729 and the smaller solid has a surface area of 225. So I can create a ratio out of that. So the ratio for their areas is going to be 729, and I made this really small, and that's going to be to 225. All right. Remember, what I normally do first, and what I suggest you do, is simplify that ratio if you can. Those are two big numbers, so if you aren't sure, you can. I'm going to go ahead and show you a little trick. So you're going to go to Desmos, all right, and you can type in GCD, put your parenthesis, and then you're going to put your two numbers that you want to see if they have a factor, a similar factor. So we're going to type in 729 and 225, sorry. All right, and notice they have a common factor of 9, all right? So we're going to be able to divide 9 out of both of them. So I'm going to go back here. We're going to divide 9 out of both 729 and 225, and that's actually going to give you 81 to 25. And that's going to help us a lot going forward. Okay? So now we want to go and find the ratio of the scale factor. So we're going to try and get back to that linear. So we're going backwards. Whenever we go backwards, we root it based off of what we started with. So we're going to square root both of those. So the square root of 81 is 9, and the square root of 25 is 5. So I'm going to do that first. So step 1 done. Next, we're going to calculate our desired ratio. Our desired ratio is our volume ratio because we're trying to find that volume of the smaller solid. So now I'm going to go forward. Whenever I go forward, I raise it to the power of whatever I'm ending it with. So I'm actually going to cube both 9 and 5. So 9 cubed is actually 729. And 5 cubed is going to be 125. All right. So once we have that desired ratio, we can go ahead and set up our proportion. So we know that we can turn this into a fraction. So that's going to be 729 over 125. That's going to equal to, we know that we want the larger one on top because that is our larger number here. So the larger solid is going to be, the volume is 12,393. Whoa, that's big. All right. So then we want the smaller one on the bottom, and we are not sure. That's what we're looking for. Once you get there, you can cross multiply. So I'm going to do 729 times x, which is just 729x, which is equal to 125 times 12,393, which is 1,549,123. All right, once we have that, we want x by itself, so we're going to divide by 729. And dividing by 729 is going to get us that x is equal to 2,125. So this is the volume of a smaller solid. So that means that we need units as well. And we're just going to take the units from the bigger solid. So that is going to be meters cubed. And that's going to be your answer right there. Go ahead, pause this video, and then you can try it yourself and come back to see how you do. All right, so let's try this second one. I hope you were able to do it on your own. So again, our first step is to find that ratio of the scale factor. In order to do that, we need our chart. We now have the volume. So we know that the volumes is 625 to 40. We're going to simplify that if we can, and we can, in fact, to 125 to 8. All right, taking 5 out of both of those. So now we want to find the ratio of our scale factors first. So we're going to work our way backwards. Whenever we work our way backwards, we're going to root based off of whatever we're starting with. So we're going to take the cube root of both 125 and 8. So the cube root of 125 is going to be 5, and the cube root of 8 is going to be 2. All right. So step 1 done, we got the ratio of the scale factors, but now we need our desired ratio. And we are looking for this missing surface area here. So we want to get the ratio of the areas. So we're gonna go forward. Whenever we go forward, we're gonna raise to the power of whatever we're ending with. So 5 squared is going to be 25. And 2 squared is going to be 4. So that is our desired ratio. We're now going to bring that down. So we have 25 over 4 is equal to 325 over x. Then we can cross multiply and solve from there. So 25 times x is just going to be 25x. Divided by 325 times 4, which is just 1,300. And once we get there, we want x by itself, so we're going to divide by 25 on both sides. And we get that x is equal to 52. And then we're going to take the same unit, so centimeters squared. That's going to be your answer. All right. So we're going to use those ideas to help us with this next part here. And in this case, we're going to be given the similarity ratio. So we're going to be given our scale factor, or our L column. And we are going to have to find a missing surface area and a missing volume. So we're going to have to set up 2 proportions in this case. So we have that our linear is 4 to 9. So now area and our volume are both desired. So we're going to go to area first. To get area, we're going to square 4 and 9. So 4 squared is 16 and 9 squared is 81. And moving forward, we want to cube it to get our volume. So 4 cubed is 64. And 9 cubed is 729. All right. We're trying to find the surface area and the volume of the larger similar solid. So we're given the smaller one, and we're trying to find the larger one. So now we're going to use those two ratios to set up two separate proportions to help find the smaller surface area, the larger surface area and the larger volume. So I'm going to set up my 16 over 81 here. All right. And we're given that the smaller one is 80 inches squared, so that's going to go on top. And we're looking for the bigger one, so that's going to be x. We're going to cross multiply, so we have 16x is equal to 81 times 80, which is 6,480. Divide both sides by 16, so that's going to get us that x is 405, and then we're going to take our inches, and we're dealing with area, so that is going to be squared. So we just got the surface area for the larger similar solid, so now we want the volume. So we're going to take that desired ratio that we just got, and we have 64 all over 729. We're going to set that equal. We know that the smaller solid is 1,792 all over x. We're going to cross multiply again. So 64x is equal to another big number, which is 1,306,368. All right. Divide both of those by 64, and x is going to get you 20,412 inches cubed is going to be the volume for your larger similar solid. Go ahead and pause the video, try the second one on your own, and then come back and check to see how you have done. All right, I hope you were able to do it on your own. If not, let's walk through it together again. So we have the linear, we have our area, and we have our volume. Remember, in this case, they gave us our linear or our scale factor, which is going to be 3 to 5. We are again trying to find the surface area and the volume of the larger similar solid given one surface area and volume of the smaller similar solid, which means we need both of those as our desired ratios. So we're going to move forward. In order to go forward, you're going to raise it to whatever you're ending with. So we're going to square it. So we have 3 squared is 9 and 7 squared is 49. All right, but we still need our volume as well because we're going to look for both the missing parts. So we're going forward again. But in this case, we are now going to cube it. So 3 cubed is 27. And 7 cubed is 343. Okay. Now we're going to use both of those to set up a proportion in order to solve for our larger similar solid. So now we have 9 over 49, which is going to be equal to, we know that the smaller area is 9. So we can cross multiply if we need to. But in order for this fraction to look exactly the same, we know that we have 9 on top. So what must we have on the bottom? It has to be exactly the same. So x is going to equal 49 meters squared. All right, so now let's look at the volume. So now we have 27 over 343. which is equal to, we know the smaller volume is going to be 675. Looking for the bigger one. We're going to cross multiply, so we get 27x is equal to 231,525. You're going to divide 27 on both sides, and you're going to get 8,575. And our units are going to be meters cubed. And that is going to be your volume. All right. So that is the end of video 2. Go ahead and continue with video 3 to finish up the notes. Thanks for watching.